what this is telling you is that the fish is more dense than fresh water. It is more dense than salt water. That means that a fish then has the tendency to sink when it is in the water. So it is not buoyant. Instead, it will sink. How do fishes overcome this? Because obviously not all fish live on the bottom. Well, there's a number of different ways in which that can be done. One, you can expend energy. This is something that many sharks will do. So sharks swim through the water and they create lift using their pectoral fins. Sometimes, depending on the shape of the fish, it could be lift from the body itself. But in order to create that lift, they have to keep swimming. So it's very energetically expensive to overcome their density problem by continually swimming. It can be done, some of them do it, but it is energetically expensive. Another one is that you can fill your body with materials that are less dense. A number of fishes will do this. Many sharks, for example, have a lot of oil inside their livers. So if you ever take comparative anatomy and we dissect a shark, it's a very greasy, very oily animal. Well, most of that oil is packed into the liver, and it helps to adjust the overall density of that fish to make it closer to the seawater in which that shark is living. Latimeria uses waxes. There are other chemicals that could be used by certain fishes. You can reduce your skeleton. Okay, your skeleton is the densest part of you. It's made out of that mineral, hydroxyapatite. So you can adjust, lower your overall specific gravity by decreasing the amount of bone or the density of bone that is in your skeleton. And this actually is accomplished by many deep sea fishes. So they will decrease the amount of bone compared to their ancestral relatives. And that allows them then to have a buoyancy, specific gravity that is closer to that of the surrounding water. And the fourth, as you might have guessed, is to use air. We can adjust the amount of air inside a gas bladder. And by adjusting that amount of air, we can be neutrally buoyant. Neutrally buoyant means that you're not sinking, you're not rising. And that's good if you are a fish and you want to stay at 5 feet below the surface or 100 feet below the surface. You want to be neutrally buoyant because then it's not going to take you any energy to adjust your position. There's a problem, though, if you use air compared to, let's say, oil. And that is that air obeys Boyle's law. Anybody remember what Boyle's law relates? Y'all?
Compressed. You can compress it.
Compress what?
The air.
Hey, we're getting there. Boyle's law is the idea that the volume is proportional, inversely proportional to pressure. So the volume of air is inversely proportional to pressure. Okay. Right, so this is a problem. Why is it a problem? Well, think about it. You have a certain amount of air in this gas bladder. And let's say the fish is going to go down 100 feet. It goes down 100 feet. That's a huge increase in pressure. That is going to decrease the volume of air that was inside the bladder. If you decrease the volume of air, you effectively increase the density of the animal, the overall density of the animal. So when the fish stops at 100 feet, it will continue to sink because it is now denser than the water. It was neutrally buoyant up on top. As it came down, the air in its bladder was compressed. The volume of the air decreased. Therefore, the overall density of the fish increased, and it continued to sink. The same thing would happen as it comes up. If it's neutrally buoyant at 100 feet, it goes up to 10 feet. As it goes up, that gas expands. So the volume of gas now is much greater than what it was before. When the fish stops at 10 feet, the tendency would be to keep on rising because it is more buoyant. It's less dense than the surrounding water. So if you're going to use air in order to adjust your buoyancy, you have to have a flexible system. You have to have a way of getting more air into the bladder when you need it, and you have to have a way of letting air out of the bladder when you want to decrease the volume that's in there. Okay? Is that clear? The idea that the density, the pressure of that water will increase